Good afternoon, fifth graders. Welcome to your first video for Unit 3. By the end of this video, you should be able to describe a general pattern in words and write special cases for the number pattern. The vocabulary for this lesson is the words general pattern, special case, and variable. Please pause the video now and write down your learning goal and your vocabulary in your Cornell Notebook. Alright, we're going to get started by just talking about what a pattern is. And what a pattern is the repetition of a set of lines, colors, shapes, or designs. So a pattern you might recognize would be with shapes, and you've done things like this since kindergarten. We have 3 triangles, 2 squares, 3 triangles, 2 squares. That would be a pattern. You can also do a pattern using colors. Maybe. So here we have 2 red, 2 yellow, 2 red, 2 yellow. So the pattern is the repetition of a design or colors or shapes. In math, we also find patterns, and the patterns we find in math are called general patterns. They are the rules we use to solve problems. They can be described in words, and they can also be described with variables. Now we talk about a variable. What a variable is, it's a symbol that represents a number in a math problem. Now by symbol, it can be a letter, it can be a shape, it can be a box, so it can be any variety of things. A variable can also have any one of many possible numeric values. So those are just a couple things to remember about variables. And when a variable is substituted with a particular number, the result is called a special case. Once you pause the video now, and I want you to write down in your own words a definition of general patterns, the definition of what a variable is, and the definition of a special case. Alright, so let's take a look at the first pattern we looked at. In this pattern, we have a series of shapes. We have a triangle, 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 square, square, triangle, triangle, triangle. The general pattern of this, written in variables, would be AAABB. AAABB. Now we can represent this with any kind of special case. So for example, in this case I'm going to use this to represent my A. So I would have 3 in a row and then 2 of a different shape. And then 3 in a row. Oh, that's one too many. Throw him out. 2, 3, and then 2 of this shape. I'll put this one back here. That would be an example of a special case for my general pattern. I could do yet another special case for my pattern as well. So special cases are when you take your pattern and you substitute something in for the variables. And in this case, I'm substituting shapes for my variables A and B. But I'm keeping the same theme of the pattern. So 3, 2. Whoop, I didn't do it right. 3, 2. So there I have 2 special cases. So that's how you could do it with shapes. You can also do it with math problems. So let's look at this general pattern. And remember, general patterns are rules that describe patterns we see in math problems. In this math problem, we can see a pattern. In each of these general patterns, and they're all the exact same general pattern, we have 10% of, in this case, I have a square equals 10 divided by 100 times a square. I can do the exact same general pattern, but in this case, I use the variable x, and in this case, I use the variable n. Okay, so a general pattern is a rule. So in this case, to find 10% of x, I need to take 10 divided by 100 and times it by x. So let's say we're going to make a special case from this. To make this into a special case, what we would do is we pick a number to put in for the variable. One thing to remember about the variables is whatever number I substitute in for x on this side of the equation, I must substitute for x on this side of the equation. So let's say I want to have x equal 4 in my first problem. To find 10% of 4, I would take 10 over 100 and times it by 4. Okay? Let's say for the second time, I want to use 40. I then take 40 and substitute in for my variable. 10% of 40 equals 10 over 10 times 40. And this one I'm going to make x equal to 38. If I want to find 10% of 38, I use this general pattern. (10 over 100) times 38. And so here I have 3 special cases using this pattern. So when I took a general pattern and made it into a special case, you can see I kept everything that didn't change, or that were numbers, constant, 10% of, and that. And the only part I changed was I put in my variable in each of these. All right? Let's go ahead and give it a try. So let's look at this general pattern. If I had 2 times m plus m equals 3 times m, and that's my general pattern, to make a special case, I would find my variable, pick a number, a numeric value for that variable, and rewrite my special case with that number. I want you to go ahead and try to write one special case for each of these general patterns, and then we can come back and check. Okay, let's do the first one. The first one, I have 2 times m plus m equals 3 times m. My special case for this is, first I want to determine what I'm going to pick as m, and I am going to pick 3. And so I am going to say 2 times 3 plus 3 equals 3 times, oops, not m, 3 times 3. Now to check to see if I did it right, I find all of the m's. And in this case, they were here, here, and here, and I substituted my 3. So this would be an example of a special case. Now yours may be different. You maybe had m equal 8. If you had m equal 8, yours would look like 2 times 8 plus 8 equals 3 times 8. So whatever number you chose to represent m, that's where you would put it in the equation. Now the one thing to remember in a special case is you're not going to actually go ahead and finish the equality to see if they're equal. You're just writing the special case. For the second one, for this one I am going to say s equals 10. So I would have 10 plus 0.25 equals 0.25 plus 10. So once again, whatever variable you chose for s, you would have put in those spots, and everything else would have remained the same. And this bottom one, I'm going to say x equals 25. So I would have 25 squared times 25 cubed equals 25 to the 5th power. And you, once again, whatever you chose for x would be in there. So there's an example of taking a general pattern and changing it into a special case. All right, now we are going to reverse it. We are going to look at a special case, and we are going to determine a general pattern. Now, if you notice, I have 3 different equations here to show my general pattern. You should have more than one equation in order to determine a general pattern, because the pattern has to be able to repeat itself accurately every single time. All right, let's look over the steps for creating a general pattern. The first thing we want to look for is we want to look for what digits or what parts of the original equations, special cases, stay the same. So in this case, we notice that our 0.01 is in every single one of these, and our 10 is in every single one, and they are always in the exact same spot. So that's the first thing we want to notice. The second thing we want to notice is our operations. And here we have our operations, and they are exactly the same in all the equations in the exact same location. And the last thing we're going to look at is what digits or what things change from one equation to the next. So from this equation to this equation to this equation, These are the things that changed. The others stayed the same. So when I am writing my general pattern, I am going to keep the things that are the same. And what I might do is say, okay, the first digit, my 7 here, changed in each of my special cases. So I'm just going to put a line there. The multiplication sign stayed the same. The 0.1 stays the same. The equal sign stays the same. This top number changes, however, so I'm going to leave that blank. I have my vinculum, and the 10 stays the same. So now everything that stayed constant in my special cases, I am going to keep constant in my general pattern. For the thing that changed, I'm going to put in my variable, and in this case, I am going to use an S. So my general pattern would be S times 1/10 equals S over 10. So that would be my general pattern. Now I'm going to change my white here so you can see this a little better. It does not want to do that. Okay? So let's go ahead. I would like, well, this is the one we just did. So it's the same thing. I found what was constant. I kept that constant, and I changed the other parts. Okay, so I want you to go ahead and give it a try. The first thing you want to do, remember, is identify what remains constant. What thing on here remains the same in each of these problems? What changes? And that's what we'd make the general pattern on. So pause the video now and go ahead and make your general patterns. All right, so we're back. The first thing we're going to do is I'm going to identify what stays the same. In every single one of these, there's an equal sign. In every single one of them, there's a parentheses. There is a negative in front of the number in the parentheses, and there is an equal 0. So I'm going to start by putting those things down. Now my first digit in all of them changed, so I'm just going to make a line. My plus sign stays the same. My parentheses stays the same. The negative stays the same. This is one that changes in each of these here. So I'm going to leave that blank. My parentheses stays the same. My equal stays the same. And my 0 stays the same. So for these two things, I am going to make it an x. I will give it the variable x. And there is my general pattern. So I have x plus negative x equals 0. And on the bottom one, I'm going to look for what stays the same. Well, my first number changes in all of them. What stays the same is the exponent is a 0, and the equals and the 1s. So this is what changes. My exponent of 0 stays the same, my equal stays the same, and my 1 stays the same. So I will put a variable in right here, and I'm going to give this one the variable of n. So that would be my general pattern for those special cases. All right, so I want you to quick review your notes. I want you to record any questions and take the quiz before tomorrow. If you need to, go back and review the video to freshen up on the material. See you then.